So the topic of today's presentation is to talk about the Google Maps APIs and kind of give you some use cases as to how we can help optimize retail and on-demand customer experiences with these technologies. And again, my name is Nirav Patel. I'm VP of Data Sciences at Dido. And my colleague Rico Marquina is a Google Maps specialist, and he'll also be presenting today as well. And as Dido, we've been around since 2008, and we're a cloud consultancy. So we've helped a lot of companies go Google. They have over 1,200 G Suite customers and over 100 Google Maps customers. This is just a few of them that you're seeing on the slide. And we're a premier partner in different product areas, but we really want to highlight that we just got our data analytics specialization with Google Cloud Platform very recently as a business. So our company is focused on cloud transformation, custom tailored for your company. And just beyond, obviously, Maps, we offer consulting on the full stack of Google products or cloud products that you may be interested in. And so I just wanted to keep that in mind for you. And also, today we're focusing on mapping solutions on location services. And so in addition to providing consulting, licensing, and development services for Maps APIs, we have different solutions for delivery, asset management, et cetera, on the mapping side of things. And specifically with Google Maps, as you're familiar with a publicly facing application, for businesses, it helps make better decisions, help streamline operations, and deepen customer engagement. And we'll be going into that deeper today by first starting off with doing a brief history of Google Maps and Google Earth, because it's important for the overall context, talking about how Maps integration with current technologies and use cases, top Maps APIs for retail and on-demand experiences, and customer highlights as well from customers that we work with. So just to give you a brief history of Google Maps and Google Earth. So I made the ill-advised decision to do a PhD in this subject started my education back in 2008 with my undergrad, and this was about 4 years after Google Maps and Google Earth had been out on the market. What I didn't know was that Google acquired two companies in October of 2004, Where2 Technologies, an Australian-based company that was the basis of Google Maps, and Keyhole, which was a company that was acquired by Google that had this product called Earth Viewer, which is what we know as Google Earth. And so if anyone remembers sort of the version 1 of Google Maps, as you can see on the screen, this was kind of, a lot of people cite this as an example of Web 2.0, where you're utilizing sort of asynchronous calls to JavaScript and XML to, reference data interactively on a screen. And Google saw the potential of having location data, sort of like queried in this way and displayed in a useful way to the customer, and part of its mission to organize information, all the world's information. And so since then, Google Maps and Google Earth, as you know, has over 1 billion monthly users. As you can imagine, it's over 200 countries and territories all over the world are mapped. Street views in 68 countries. The stats sort of speak for themselves. 1 out of 5 searches are by location. And what we're familiar with the map interface, maybe on the top right-hand corner, there's so much underlying data that's behind the Google Maps, and just kind of just showing you some examples of how to display geographic information in the same way. And location or mapping data has sort of been the foundation for a lot of new services nowadays. I mean, if you ever use Uber or Lyft or any other ride-sharing service, any on-demand delivery services, how important location is. And especially with self-driving vehicles, it's become a foundational technology to drive innovation in many new areas in today's world. And so a lot of smart technology, quote unquote smart technology, that's been developed, for example, the Nest thermostat. If you have a smart thermostat at home, can kind of look at the outside conditions and depending on where you are and adjust the temperature depending on that. You could do customized maps now. If you're a big Game of Thrones fan, it can help map out the series for you. And having companion apps as well. A lot of applications have a location-based component that do very critical things, such as an example that's showing calling 911 or maybe something as trivial as ordering the pizza and getting delivered to your door. And just to kind of give you some examples of different use cases of what Google has, Google customers. For example, Redfin built an online real estate brokerage for home buyers and sellers, cut its failure rate on its website significantly, and built a $20 billion business that's closed that much in home sales. With Via, it's a ride-sharing service that has a flat rate per trip, a $5 flat rate in a single vehicle. Having Google as their backend has helped them grow their services to more than 12 million rides. It's enabled thousands of users to share rides every day and expanded through major metropolitan areas. And Allstate, they had created an application where it offers personalized, much more personalized insurance quotes via an application called Good Home, which kind of goes in Street View and has some interactive features, zooming down in on a house or property that you may own, and it's allowed for 350% more likelihood of somebody to request an insurance quote with their company, and increase time on the website and all these other factors. Tripping is integrated the Google Maps API in a very powerful way, we think, for retail businesses. As you can see in that box where you want to go, when you start typing in an address, just as you would, an autocomplete on a Google Maps app on your phone, it will start, allows for increasing monthly revenue because, people can rely on the location information that you're inputting in. They achieved 2 million monthly unique visitors, increased their revenue by over 2,000%, and allowed them to raise 60 million in Series B funding as well. So when we look at this image, when we're talking about looking at the Earth from the way above that 100-kilometer line between our atmosphere and space, right? If we were able to look at all the devices that are working out on the ground, right, we'd maybe see something like this, where we have temperature information, we see different applications, different points of interest, and so how these things are becoming increasingly interconnected, right? And this location data is being used, in all sorts of business applications and commercial and just personal applications. And so to kind of give you a timeline of where Google has seen the development of this, you start off with paper maps 300 years ago to about 20 years ago. You have Google Maps, MapQuest, Yahoo Maps, those days of printing out directions. And then now, in the dynamic sort of going into the intelligent and predictive era, now we have real-time traffic. You could toggle between Google Maps and Waze, which is also owned by Google, where you could figure out what is the best routes for me to travel. You might be using your GPS every day, as I do, even if I know the streets. I live in San Francisco, so knowing what exactly the real-time traffic is at that given moment can make a better decision for me when I decide to take one freeway over the other. So location is increasingly contextualized now. So, as you can see from all these little icons, whether it's, food, train, grocery shopping, where you're getting lodging, places to see, gas, whatever it is, location is more contextualized now in every single application to the end user. And so what we're sort of seeing a synergy of is that, they're, mapping, in the older days has kind of been, kind of by itself, and, the enterprise integrations weren't that apparent, but Google kind of facilitated this with sort of the Web 2.0, making a map interface easily queryable and indexable by, kind of throwing their computing power behind it. All this data that's queryable on a Google map, is supported by Google's vast infrastructure. And so the developments in consumer and enterprise are now more conjoined more than ever. And so now we look at the same image, and transport and logistics heavily depend on mapping tools. Retail heavily depends on mapping tools. Social media does as well to have drive better experiences. Insurance to do sort of claims assessments and actuarial science. Food delivery, having the accurate address, with some of our customers makes all the difference in converting and having the converting that sale. So with visualization, Google has been on the market probably the longest in terms of having the best maps and imagery. Google invests in a lot of satellite image data that's accurate down to 15-centimeter resolution, so down to 6-inch pixels on the ground, which is why you could tell different cars if you zoom down enough on a Google Maps image or Earth image. And with directions and distance as well, if you've used it in certain traffic periods, it hopefully, ideally, is diverting you from heavy traffic, and the distance calculations are extremely accurate. Um, and the amount of people, places, and things that exist in, for example, the Places API, like millions upon millions of locations that are indexable and searchable, have made this very business critical to a lot of our customers. And with movement optimization, especially with our ride sharing customers, asset tracking and navigation, real-time movement, and advanced routing algorithms make the difference from a bad customer experience to a good customer experience. And location intelligence, looking at historical data, semantic location, and applying machine learning is really critical to sort of de-risk sort of decisions about capital, right? And where where sort of resources are being allocated towards, and understanding with machine learning where the deficiency is going to be. What do we need to replace? Where is my truck going to be at this given time? This is increasingly being connected with maps. And so this is where Google is kind of pushing things, is through sort of the intelligent and predictive era of mapping, where we know that every single day at 9 a.m. I like to go get a coffee, right? So how can maps tell me here's the nearest coffee shops and here's their prices, this type of thing. So I'm going to hand it over to my colleague Rico Marquina for talking about some use cases, and so Rico, I'll let you go into it.
Yep. Excellent. Thank you, Nirav. That was a great rundown on the history and evolution of Google Maps, and really depicts how we've arrived to where we are currently. So I'm going to run down some of the features and functionalities of Google Maps as it is today, starting off with the store locator capabilities. This is definitely what I would consider the most common and most frequent use of Google Maps. This can be used by mom and pop shops up to large enterprises. So store location is critical, whether you be, again, I mentioned a small store, a doctor's office, any type of location that's going to need your customers to know where you are, which is pretty much everybody, can benefit from the store locator function. And as you can see, the APIs used, there are a total of 13 APIs in the Google Maps suite. So together, they interact to deliver a rich experience to your user. Another use case that we have, actually pretty underused, if you ask me, is the Immersive Adventure. This is leveraging Google Street View imagery and basically takes your customer to a place before they actually get there. So it immerses them and really gives them kind of a live experience without actually having to be there. So the example given is Mont Blanc, which is the highest peak in Europe. And as you can imagine, they're not as known as Mount Everest, for example. So Mont Blanc's tourist office has to compete with Mount Everest. And what they did is they actually utilized Google Street View to give people considering going for a mountain hike or ski an immersive adventure, and they can actually go look at the trails and look at the lodges that they would be staying in overnight, look at the mountains and the actual view that they would be experiencing on their own. So immersive adventure is definitely an underused feature. That brings us to asset tracking capabilities. The asset tracker is unique in that it's automation. You can track your assets in real time, and obviously you can also reduce significant operating costs by being able to optimize the routes. So if you have a truck that has to make X amount of stops, you're able to map that route in the most efficient manner, thus saving obviously time, gas, but at the end of the day, that all results in saved dollars. So asset tracking actually leads me to fleet tracking, which is very similar. However, with your assets, you weren't actually tracking, or rather with fleet tracking, kind of like Uber, as you can see in the example, it helps your business locate an actual fleet, whether it be cars or ferries or anything overseas, being a boat. So very, very similar use case here with fleet tracking, but both very, very powerful functionalities. Moving on to location tagging. I mentioned a lot of these features are underused. Location tagging is extremely powerful and can be leveraged, for example, to tag the location of a transaction. So if you're in the retail space or manufacturing or anything along those lines, you can tag the transactions and where those transactions occurred, thus giving you, the information of certain products moving in the suburbs or certain products sell more in highly populated areas, metropolitan areas. So it really gives you a lot more data intelligence based on tagging those transactions. So that's a very, very good use case. Location sharing is somewhat similar. The example that I give with location sharing, while a lot of folks are initially reluctant to share their location, and I'm one of them. I don't want anybody to know where I am at all times, right? But location sharing is very useful in the case of an emergency, whether it be a flood or a natural disaster, or simply, parents that want to know where their kids are, especially with, all of the tragedies that are occurring in schools these days. You never know, somebody might want to share their location for X amount of hours. You could tell your children, oh, if you're going out tonight, maybe share your location until you get back home, or you can share your location indefinitely until you choose to turn that off. Scenario is location sharing. Location tracking, this is also equally useful, more so for somebody, let's say, wanting to train for a marathon and they want to know the route that they took, the overall course that they ran, as you can tell with Runtastic. Also with biking applications and things of that nature, you can actually see, your total distance traveled, how long it took you to actually travel that distance, and a lot of other cool pieces of information that come from location tracking. Now, local discovery utilizes multiple Maps APIs. The most useful is Places API, as Nirav touched upon. It has millions of places of interest in the Google Places library. It is the largest library in the world of registered businesses, places of interest. So odds are, if you're not on or utilizing local discovery, you're not showing up with a lot of other businesses that are leveraging that. So when somebody does a Google search, local discovery would give them things like your business hours, obviously your location, your address. Hopefully you're incorporating Street View and helping visualize where to get to before they embark on that journey to arrive at your location. But yeah, local discovery is definitely something that sets businesses far, far ahead from those that don't. Travel planning and discovery, anybody encounters this when you're planning a vacation or trying to go somewhere that you've never been to. You want to know, number one, how do I get there? What's my arrival going to look like? And then what do I do when I'm there? So this will help you in both, picking your resort, picking your travel plans, and then actually making plans for once you arrive at a destination, utilizing, again, Places API, Geolocation, and JavaScript. So again, there's a total of 13 of these APIs all in one. There's no right way to use them. And quite frankly, our customers are who have used them in such creative ways that the product continues to evolve. The last one, I saved this one for last because it really resonates with a lot of customers. The shopping cart and checkout experience. With us moving to an age where a lot of folks, either for not having enough time or for whatever reason, they prefer to shop online. And I think it can be agreed upon that none of us like to wait in line. As a matter of fact, when I have something in hand, I typically choose not to wait in line if the line is too long. I just get it another time, right? Well, the same principle applies when we're online. If there are any extra steps or anything gets too complex, we abandon it. We just say, forget it. I don't really want this, these headphones that bad, and you move along. So a Baymard Institute study showed the average abandonment rate is almost 70%, which is pretty high. And as you can see there, Google Maps autocomplete functionality reduces that 3 to 5%. So depending on your average order, you can take that at $20 or what have you. However many customers you have traveling on your site per day, 3 to 5% could be a couple $100, could be a couple thousand dollars, or if you have high volumes of business, which a lot of businesses obviously do, we're talking, sometimes hundreds of thousands, if not millions of dollars lost. So I really like this slide because it's not necessarily how much does it cost you to take advantage of Google Maps. I really wanted to resonate with folks the cost of not taking advantage of Google Maps, because there are significant dollars that are going out the door simply because folks either don't know about the technologies available or haven't figured out a way to use them in their particular use case or in their scenario. So I hope that was useful. And with that, I'm going to kick it back to Nirav. But I hope that inspired a few questions that we can address towards the end.
Thank you, Rico. So back to sort of talking about the Google Maps APIs and details, kind of what kind of is in the background of these different use cases. So when we're looking at the Maps APIs overall, like Rico mentioned, there's 13 different sort of web services. Some of them are listed here, and then there's web and web services, different sort of products for Android and iOS. I'm just going to go briefly over them, and obviously we could talk about this more in detail afterwards as well, outside of the webinar. So in terms of the web services, the JavaScript API is the main one that everybody's familiar with, right? So if you go to maps.google.com and you load that up onto your browser, what essentially you're doing is you're calling the JavaScript API to call the map tiles for the entire world, essentially, for Google. So one sort of call to the JavaScript API gives you this full visualization of the entire globe, and you can zoom down in and out as much as you want. And it has all these different functionalities where you could kind of build this on top. For example, everyone's familiar with directions, street view, geocoding, converting an address to a point on the map, or vice versa. And so this is the JavaScript API. And the Places API web services. So kind of as Rico was touching on the sort of abandonment that happens, with not having the most optimal sort of checkout service. Is the autocomplete functionality. So whenever you start typing in an address, this web service allows you to fill in the details and predict whatever you're going to say, and tries to reduce the pain of typing out your entire address every single time. Then it has a lot of good business intelligence functionality, like such as places search, so querying like different businesses in an area that have a certain feature, and being able to use that for your own intelligence. And yeah, it allows access to the millions of photos stored in the Places and Google Plus local database. The Places API for iOS and Android is a similar functionality. The iOS SDK is available via CocoaPods, and the Android SDK is available via Google Play Services, has a similar functionality. The Geocoding API, as I mentioned, this is what the bread and butter of any map service. How accurate can you convert an address like 1600 Amphitheater Parkway, Mountain View, California, to geographic coordinates with a latitude, longitude, to place in a marker accurately on a map, or position sort of a marker on the map and derive an address from it. The Geolocation API will allow to find the location of your visitor. So, when you visit a website and it gives you that pop-up box that says, is it okay for me to use your location? This is a geolocation functionality. And so it can locate, via cell towers or Wi-Fi nodes that, your client's using, and basically will allow for you to understand where your customers are utilizing your service or product. The Directions API is another thing that everybody's familiar with. What's very interesting is that with the Google Maps product, you could have up to 23 waypoints. If anyone's tried this on the publicly facing version, you probably get capped out at 9 or 10. But basically, this allows for several modes of transportation, including transit, driving, walking, or cycling. You could specify origins or destinations, using text strings or waypoints. It's a very, very powerful tool, and it does involve massive amounts of calculation. There's a reason why there's a 23 waypoint limit, if that makes any sense. The predictive travel time is a new functionality as well that's been integrated. And what's really cool about that is that you can kind of estimate if I leave on a Friday at 5 p.m. going from this point to this point, what's the average traffic time? And Google has collected information on that, so it can allow you to organize your trip based on these things. Distance Matrix API can allow you to calculate travel distances and times between a matrix of origins and destinations. So it can kind of, the information return can give you the recommended route between start and end points. And so it's essentially directions API applied to a matrix of different locations, and wanting to see what would be the possibilities of me going from point like A to C, or B to D, or D to A, like instantaneously. In predictive travel time, I kind of touched on this. You want to help your users get where they're going faster, or help your fleet or whatever it is figure out what is the best time to leave to go to a particular location or arrive at a particular location, and it uses historical time of day or day of week data. The Roads API is a newer service as well that also improves data visualization through doing snap to road, like collecting data points that you might be getting from your fleet and snapping it to a road location, and also can return posted speed limits for different road segments. And so that kind of caps out kind of a brief overview of all the different APIs and some of the details that are associated with it. And what we kind of want to touch on is customer story that we had. So that started off as a Maps customer, and now it's sort of like integrating Google Cloud services, in terms of the predictive analysis. And so the company that we've worked with for several years now is Assessor Systems, based out of Louisiana. And they essentially do tax assessment for counties. And so they look at homestead exemptions and seeing whether people are committing fraud or not, and essentially evaluate that. And their process beforehand, they just had like, an internal maps use case with Google Maps, where they would have their records of what they were looking at for a given county, and had sort of their human, had their employees like utilizing, sort of human eyes to see inconsistencies in sort of voter information or certain tax information to see if homestead exemption fraud was being committed. And so what they did was they used Maps initially, and they're still using Maps, but what we helped them do kind of to help with prediction is migrated their IT infrastructure into Google Compute Engine, and helped develop an automated tax audit machine learning system that allows for 85% more of an efficient analysis of property tax audits and automation of real-time tax evaluations. And so what this does is it looks for similarity between different data sets like DMV records, voter records, other publicly available records, to see how similar these things are, and if there's any inconsistencies that are seen, then there's a more likelihood of exemption fraud being committed. And so there's different services used here. There's network services from GCP, cloud storage, Compute Engine, supporting Windows and SQL database servers, App Engine, BigQuery, and machine learning such as custom things that are written in TensorFlow, and also Prediction API. And so these are just an example of how your business can integrate machine learning to mapping information, for example. And kind of dovetail on that discussion, we talked about Maps in this conversation, but Maps, obviously integrates machine learning via Street View images and parsing through local search, and it kind of spreads through all the products. In Gmail, you might notice, it gives you suggested responses based on what somebody sent to you. Google Translate API is very popular, and every single, when I travel internationally, I try to save translations like of, how do I get to the train, or, how can I get to the restaurant, or how can I buy a SIM card, these types of things. And if you ever wonder why you're on YouTube way longer than you should be, that's because YouTube has done a very good job in doing recommendations and doing that autoplay functionality. So you end up spending 2 hours of your workday on YouTube. So there's a lot of different things that Google's integrated machine learning. It's pervasive through all their products, and also with photos as well. Very popular, categorizing images in the self-driving car, of course. And yeah, so that concludes our presentation. We wanted to open it up for questions. If you wanted to place it in the chat, and yeah, we want to help you leverage your location data and develop geospatial solutions. And we're more than happy to support that. Follow that link and it'll help you kind of get in touch with us. And yeah, thank you very much for your listening in today with us.